we are going to discuss about transformer parameters. Now, transformer parameters in primary side as well as in secondary side are represented separately. In primary side, the transformer parameters are R1, X1, RM, XM and E1 and N1, whereas the parameter in secondary sides are R2, X2 and E2. In transformer, at the voltage across the load is V2 when current is flowing in the circuit is I2. The transformer equivalent circuit diagram can be drawn by representing the primary side parameter in secondary side and vice versa, and that's what is known as parameter referred to either side of transformer. Means these secondary parameters can be represented in primary side, whereas these primary parameters can also be represented in the secondary side. But there are two conditions to transfer these parameters or to refer these parameters from one side to another side. The condition first is equivalent voltage drop in either side remains same. Means whatever voltage drop in this R1 due to the flow of current I1 dash, the percent of that voltage as a function of V1 should be same when this resistance R1 is represented in secondary side in reference to V2. Similarly, the voltage drop in X1 should be same when it is represented in secondary side. When it is represented in secondary side, let resistance R1 will becomes now R1 dash. Similarly, when reactance X1 is represented in secondary side, the reactance will become X1 dash, and this X1 and this can be represented in series with this circuit. This is x1 dash. Now the representation of these parameters, similarly this rm and xm can also be referred to the secondary side, and this will be in parallel with the circuit. The another condition is when referring the parameter from primary to secondary side, the total power loss in the element in either side remains same. Means the I square loss in this resistance when it is in primary side must equal to the I square loss when it is represented in the secondary side. Similarly, with the I square x loss in primary side must equal to the I square I square x 1 dash loss in the secondary side. Now the parameter primary to secondary. When let me consider first parameters are referred from primary to secondary side. According to the first condition, the voltage drop in resistance R1 when current is flowing in this resistance was I1 as a function of V1 is I1 R1 upon V1. It should be equal to when this resistance R1 is represented in secondary side. Now it is R1 dash new representation R1 dash. The voltage drop in this new R1 dash is I2 R1 dash, because now in this circuit current flowing is I2. Earlier it was I1 as a function of V1, and hence we can say percentage of voltage drop in both sides must equal to satisfy first condition. And from these two equations, rearranging these two equations, we can find out R1 dash as a function of V1 V2 and I1 I2. And we know by the definition V2 by V1 is nothing but K, and I1 by I2 is nothing but K, and hence K into K will be K square. We can say when resistance R1 is referred to secondary side from primary side, then it is R1 dash, and which is equals to K square times of R1. Similarly, the same condition is applied to reactance. When the reactance was in primary side, the voltage drop in reactance was I1 X1 as a function of V1 divided by V1, whereas when this reactance X1 is referred to secondary side, it has new representation, that is X1 dash. Now the current flowing in this X1 dash is I2, and hence voltage drop will be I2 X1 dash, and as a function of V2 it is taken as V2. Now rearranging this again this equation, we can find out x1 dash. Now the x1 dash will be equals to, considering this transformation ratio, v2 by v1 is equal to k, I1 by I2 is equal to k, then k square x1, and hence similar to the r1 dash, we can conclude that x1 dash will be equals to k square times of x1. Now considering the core parameters. In case of core parameter, the resistance of the core is Xm, whereas the reactance of the resistance of the core is Rm, whereas the reactance of the core is Xm. When because Rm is connected in parallel with the circuit, the first condition cannot be applied. Therefore, we are applying the second condition. Means the loss in the primary side, when this Rm is represented in primary side, the loss in Rm is I square R. V1 upon Rm is nothing but IW. IW square Rm. This is the loss, and this loss must equal to the equivalent to the value when it is represented in secondary side. The secondary side representation is Rm dash, and hence the current in the secondary side will be V2 upon Rm dash, and then it can be written as equal. These two value must be equal, so that we can say primary parameter is referred to the secondary side. We are rearranging this equation, it will give us Rm dash is equal to V2 by V1 whole square into Rm, and hence it is K square Rm, similar to R1. Similarly, we can apply the same condition. The power loss, equivalent loss in primary side must equal to the equivalent loss in secondary side, and rearrange these two equations, and we can find out x1 dash is as a function of k square xn. Again, it is multiplier of k square as we are having in case of x1. x1 dash was equal to k square x1, whereas r1 dash was equals to k square r1, and hence similar condition we can apply for Rm and Xm. Now, when the parameters resistance and reactances are represented in secondary side, the equivalent impedance referred to the secondary side will become total resistance of the circuit R2 plus R1 dash, because in secondary side now we are having a two component R1 dash and R2. The total resistance is R2 plus R1 dash. Similarly, we are having two reactances in the secondary side. One, it is total reactance, it will be equals to x2 plus x1 dash, and this is the we are knowing x2 r2, this is r2 equivalent is equal to, this is x2 equivalent is equal to, and hence we can say z2 equivalent is equal to r2 equivalent plus j x2 equivalent, and that's what is represented over here, where R2 equivalent is R2 plus R1 dash, and X2 equivalent is, this is R2 equivalent, this is X2 equivalent, and this is Z equivalent in the secondary side. Now, considering when secondary parameters are referred to the primary side, it means the voltage drop in the secondary side must equal to the percentage voltage drop in primary side. When resistance was in secondary side, it was R2, the voltage drop was I2 R2 as a function of V2, that is why taken as divided by V2. When this R2 is represented in primary side, now it will become R2 dash. The current flowing in primary side is I1, the voltage drop in R2 dash will be I1 dash, and into my R2 dash divided by V1 as a function of V1, and hence we can find out R2 dash when referred to the primary side, it is equals to R2 by K square. In case of parameter primary to secondary, it was K square into the original value, whereas in case of secondary, the original value divided by K square. Similarly, for reactance, the percentage voltage drop in secondary side must equal to percentage voltage drop in primary side. Then equating these two equations as a function of V1 and V2 and rearranging for x2 dash, it will comes to be x2 by K square. Earlier it was multiplied by K square for primary to secondary, but in secondary to primary it is divided by K square. Now, in primary side, the equivalent resistance will become R1 plus R2 dash, whereas the reactance will become X1 plus X2 dash, and this is represented by R1 equivalent, this is represented by X1 equivalent. Therefore, Z1 equivalent is equal to R1 equivalent plus JX1 equivalent, and that's what is this. This is R1 equivalent, this is X1 equivalent, and hence equivalent impedance in primary side will be the sum of phasor sum of these two quantities. However, Rm and Xm, these two components already were in primary side and hence need no transformation or no reference.